Okay, we're going to move on to the next topic of integration, which would be definite integrals. The technique I showed you before was known as an indefinite integral, and um, where we learned that the integral of f of x dx can be interpreted as the area um, under the f of x graph bound by the origin, the value of x, and the x-axis. The other way of saying it, the origin, I could also have said the y-axis. So, for example, if I had the following graph, if I had the function f of x that looked at something like this, the value of the integral at the value of the integral at x is this area. It's the area from the origin out to the value of x, bounded by the curve f of x and the x-axis. Whoops. Apparently that gesture means erase. And the x-axis. So that will give me the answer of that particular integral. So when I'm done with this integral is going to be some new function, g of x. So that means I can take an x value, a specific x value, substitute it into my answer, g of x, and it will give me the area bound in that region. If I put in a different x value, for example, if I put in this value of x, g of x would give me this area instead. So there's a new type of notation that we can worry about, and it's called a definite integral. If I write the integral of f of x dx from a to b, that's how you say it. This would mean the integral of f of x dx from a to b. A is the left-hand limit, and b is the right-hand limit, or the lower limit and the upper limit, or the starting value and the ending value. So what we would do is this integral means the following. If I had a function, there's my function, and I have an a value and a b value. If a is here and b is represented, say, here, then this integral means the area bounded on the top, or bounded by the function, the axis, and starting at a and ending at b. This is known as a definite integral. This comes from the definition of the regular integral, the indefinite integral that we had been talking about. The value of the integral from a to b of f of x dx is equal to the integral of f of x dx out to b minus the integral of f of x dx out to a. So imagine starting at the origin and going to this final limit. If I can highlight that, the area in yellow that I'm highlighting would be the answer to this portion of the integral. Right? Because it would give me the entire value of the integral starting at the 0 point all the way out to b. That would be the definition of the indefinite integral. So we would think of taking the indefinite integral and evaluating it when b is equal to x. And then if we take this section, . That would be this section. And what I probably should do to make it clear, let me do some erasing here. That makes it a little, maybe a little bit clearer, but not entirely. So if we took the original yellow area minus the pink area, that leaves us with this cross-hatched blue area. So a definite integral is the area under the curve bounded by the axis, starting at the left-hand lower limit and ending at the right-hand upper limit. Let's show you how you would actually do that mathematically. So if I had the integral from 1 to 3 of x squared dx, this would become, taking my integral, x to the third over 3 is my answer to my integral. But now I have to figure out what to do with these limits. And what I do is I put a vertical bar here, and I say I'm going to evaluate this thing from 1 to 3. That's that same idea of figuring out what is the value of the integrals bounded by those upper limits. So what I do is I first take the top limit and I substitute it in. So this would be 3 cubed over 3, which would be 27 divided by 3, which would be 9. Um, get rid of my equal sign there. Uh, that's the evaluating the integral at the top limit, and then I subtract away, just like this minus sign here. This is where this minus sign comes from. I subtract away the same exact answer evaluated at the lower limit. So this would be 1 raised to the third all over 3. So you always evaluate a definite integral as take the top value substituted in your answer minus the bottom value substituted into your answer. And so in this case, I would get 9 minus 1/3, or 8 and 2/3 would be the answer. And you'll notice I get no plus c. Plus c is missing over here. Um, you don't need it on the definite integrals because it would be common to both of them. This would be the integral of f of x dx plus c, and then this one would be the integral of f of x plus c. And when you subtract, look what happens to the minus c's. They're common to both terms. They would subtract away. Something to know about definite integrals that's different indefinite integrals. Next up in integrals will be a conversation about a variety of techniques and memorization of different integral forms.